If we have a division of the same base, we subtract the exponents. That becomes the exponents in the numerator, subtract the exponent in the denominator. Or another way to remember this, when x raised by something appear in the denominator, that's x raised by negative exponent of that. So 2 raised by 9 divided by 2 raised by 8, that's just 2, right? It's 2 raised by 9 minus 8, that's 2. So x raised by negative n, that's 1 over x raised by n. Okay, so x raised by n appears in the denominator. We indicate with a negative sign. But if we have 1 over x raised by negative n, so the negative exponent appears in the denominator. So that turns out to be positive, x raised by positive number. Because negative negative equals to positive. Right? Example, half can be written as 2 raised by negative 1. 1/8 can be written as 2 raised by negative 3. But if we have 1 over 2 raised by negative 3, that's 1 over 1/8. So that becomes 8. 2 raised by negative 3 appears in the denominator. It turns out to be 2 raised by positive 3 in the numerator. If we have a negative exponent in the numerator, we turn it to denominator with a positive exponent. If we have negative exponent in the denominator, we turn it to the numerator with a positive exponent. All right. Okay, if anyone has any questions at any time, feel free to stop me, all right? Okay, square and square root, okay, are totally different. It's the opposite. Square and square root are opposite operations, like a plus and minus, like a multiplication and division. So square undo square root undo square. Opposite operations, all right? So what is this 5 square? Well, that's 25, right? It's called the square of 5. What is the square root of 25? That's 5, because square root of 25 is the square root of 5 square undo square root, so that becomes 5. Or we can think 5 square is 25. Oh, actually positive negative 5, because negative 5 square is also positive 25. So what is the square root of 5? Square root of 5 is an irrational number, all right? Which means something squared to be 5. So if we have n squared equals to n, we can write n equals to square root of n. Well, here is for n greater than or equal to 0. If n is negative, we would write n equals to negative square root of n. Right? In other words, square root of n squared is absolute value of n. What's the example? Example is like this. If we have square root of negative 5 squared, first we square negative 5. Square of negative 5 becomes positive 25. So square root of 25 is 5. But if n is positive, that's okay. It's just square root of square is itself. But if you have a negative sign before square root, so that stays to be negative 5, because this negative sign has nothing to do with the square and square root. And this one too, the first negative sign has nothing to do with the square or square root. But the second negative sign is being squared. So that's negative square root of 25, that's negative 5. Sometimes this can be confusing, okay? Just make sure you follow the rules. Square root of 9 is 3, square root of 25 is 5, square root of 121 is 11, negative square root of 9 is negative 3, negative square root of 25 is negative 5, Plus minus square root of 121 is plus minus 11. Square root of 0 is 0. Square root of 1 is 1. Okay, those two numbers are special. It's just itself. Let me actually just add here. Square root of 0 is 0. Oops. Right, square root of 1 is 1. Those two numbers are special. Oops, I cannot do that. So those two are special. Square root of 0 is 0. Square root of 1 is 1. What about square root of negative 9? Square root of negative 9 means something squared to be negative 9. So not in real number system. It's called an imaginary number. So what do? We just define I squared equals to negative 1, or I equals the square root of negative 1. We cannot use it in real life, but it works in science. It's like a bridge. It's like a bridge for science, and it's very useful. So let's see this. So what is the square root of negative 9? And that's the square root of negative 1 times 9. What's the square root of negative 1? That's I. Square root of 9 is 3, so that's a 3i. All right? 3i. And the complex, also we call complex number a plus bi. A is a real number, bi imaginary number. So we have two parts. Let's see 3 plus 2i. We have the real part is 3. The imaginary part is 2. We'll talk more about this, all right, when it comes. But if x equals negative 3, x squared equals 9, x cubed equals negative 27, x fourth equals 81, x raised by 5 is negative 243. So what pattern do you see? Even power will change a negative number to be positive number. But odd exponent keeps the sign, right? Negative 3 raised by 3 is negative 27. All right, so our focus is nth root of a number. Okay. If we have a equals b raised by n, right? N is called the exponent or power. B is called the base, right? A equals b raised by n. B is the nth root of A. Right, so in other words, we could write this way. We could write B equals to nth root of A. And n is called the index. So n here, so this n here is a power, but this n here comes with this sign, okay, together with this sign, and it's called index. The principal nth root of A is written as B equals to nth root of A. Okay, it's read as nth root of A. N is called the index of the radical, and this sign is called the radical sign, right? Radical sign, nth root of the radical. Let's see an example. So we have 2 raised by 3 equals 8. In another way, we can write this as a cubic root of A equals to 2. So, so equivalence is 2 equals to cubic root of A. Why? Because A is 2 raised by 3. Remember the same power and do its root. right? Cubic root, if it's a square, square and do square root. Sorry, let me close the window. Too noisy. So here, the power 3 and the index 3 undo each other. Okay, opposite operation. So that's why we just get 2. So this power 3 and this index 3 undo each other. 3 raised by 4 equals to 81. So 81 is 3 to the power of 4. Then we can write 3 equals to 4th root of 81. 81 can be written as 3 raised by 4, right? 4, the power 4 and the index 4 undo each other. Negative 5 raised by 3 is negative 125, right? That means negative 5 equals to cubic root of negative 125. Negative 25 is negative 5 raised by 3. So 3 undo index 3. Negative 3 squared is 9. So square root of 9 is 3. Negative square root of 9 is negative 3. Be very careful with this sign when sign is involved, all right? But what about the square root of negative 3 squared? We have the square negative 3 first. That's square root of 9, that's positive 3, all right? Just be careful this not, let me make a note here. Note, oops, gotta change my language. Note. It doesn't equal to 3, okay? Oh, doesn't equal to negative 3, all right? Be very careful. Because with the square root, it's different. With even, right? With the even power and the index, it changes things. But negative square root of 9 is negative 3, right? So a raised by n, then mth root, so mth root of a to the power n. So equals to a if, let me change this to be black color. If the index m equals to the power n, right? Because we can rewrite this mth root of a to the nth power to be a raised by a fraction. The numerator is a power, the denominator is m. If n equals m, that's just a raised by m over m, right? It just becomes 8. To special case. Well, let's do some exercise. So we have square root of p squared. That just equals to p, right? If p greater than or equal to 0. Or equals to negative p if p is less than 0. Hold on. Right. If p is negative, we have to put a negative sign in front because negative and negative become positive. If we have p raised by 4, then square root, that's just p squared, right? Or p raised by 4 divided by 2, that's just p squared. M to the 6th power, that's m raised by 6 divided by 2, which is m cubed, right? Actually, this we should put an absolute sign to force m to be positive, or at least a negative, because the power is 6, right? So 6 will make sure m is positive, but m itself, we don't know. M to the 6th power has to be positive, but m itself could be negative, so let's put the absolute sign. Because it's an even power, all right? If it's a cube, odd power, we don't care. This is a y. Y could be positive, y could be negative. Y to the 6th power, then cubic root, that's just a y squared, right? Because 6 divided by 3, that's 2. So nth root of y raised by m, we write as y raised by m divided by n. The power is the numerator, the index is the denominator. So if we have a cubic root of y to the 6th power, we get a y to the power 6 divided by 3, which is y squared. Let's see properties of nth root of a. When n is an even number, right? If a greater than or equal to 0, then nth root of a is defined in real number system. If n is less than 0, then nth root of a is not defined in real number system, but in complex number system. When n is not odd number, when n is odd, so nth root of a is defined for all real values of a, right? Because a can be negative. What is the domain of square root of x? Well, x, real number system, right? The smallest value x could be 0, then can go up to past infinity. What is its range? Its range also goes from 0 up to past infinity. What about the domain of cubic of x? All real numbers, right? All real numbers. What is its range? All real numbers. Anyone has any questions? Okay, let's see section 2. So sometimes, a lot of time we can simplify radical expressions. If we have something called like radicals, we can add, we can subtract. Right? If we have the same index, we can combine the radicals, we can multiply, we can divide. Let's see square root of 5. Well, 5 is a prime number. Square root of 5 is simplified already. But square root 9 is not, because square root 9 is 3. Let's see some examples. Square root 36 is 36 raised by half. 36 is 6 square. Well, then 2 layers of exponents, will multiply them. 2 times a half is 1. So get 6. Well, maybe you remember 6 square equals 36. That's why square root of 36 is 6. Cubic root of 64, right? 64 can be written as a 4 cube. Then cube and 1/3 multiply become 1. Okay, I have a question here. Let's see. To clarify, in square root, the x cannot be negative. X cannot be negative in square root. You're right. You are right. Square root inside cannot be negative, but cubic root can. So even index, it has to be positive. But for odd index, could be positive, could be negative. Okay. Okay, product property of nth root. Let's see, if we have nth root of A, we have nth root of B, and we can, if we have nth root of A times B, we can split into 2. Nth root of A times nth root of B. Well, opposite is if we have nth root of A times nth root of B, we can put them together, nth root of A times B. Example is the following one. If we have 4 times 5, square root of 4 times 5, the same as square root of 4 square root of 4 times square root of 5. But pay attention to the bottom two, right? Nth root of a plus b cannot be separated, cannot written as nth root of a plus nth root of b. No. Okay, so the bottom two are not equaling to each other because not multiplication. Only multiplication and division can change. But nth root of a plus nth root of b is not nth root of a plus b. Okay, those two expressions are totally different. Let's see some examples. Remember, we want to simplify radicals. Let's see square root of 8. Because it's a square root, so we're hunting for squares, because square will undo square root, right? So 8 can be written as 4 times 2, or 2 squared times 2, because it's 2 cubed. That means 2 squared times 2. Or 2 squared, the square undo square root. So it just becomes 2. So it becomes 2 radical 2. Square root 12, that's a square. 4, right? 4 is 2 squared. So square root of 2 squared is 2. That's 2 radical 3. Square root of 18. Well, 9 is a square. Square root of 9 is 3. So that's 3 radical 2. Square root of 24. 4 is a square, right? So that becomes 2 radical 6. Anyone has any question? Okay. Let's see cubic root. Cubic root of negative 24, right, can be split as negative 8 times 3. So we can do cubic root of negative 8 times cubic root of 3. Or cubic root of negative 8 can be written as cubic root of negative 2 raised by 3. Negative 2 raised by 3 is negative 8. Then cubic root of 3 equals, to simplify this, negative 2, right? All these two together, right? Cubic root of 3. So negative 2 cubic root of 3. Negative 2 cubic root of 3. Square root of 72 can be written as square root of 2 times 36. Or square root of 36 is 6 squared. So that's simplified to be 6 radical 2. Fourth root of 81 divided by 16. Well, 81 is 3 raised by 4. 16 is 2 raised by 4. So we can combine those two rather as 3 over 2 raised by 4. And power 4 cancels out the index 4. So that just becomes 3 over 2. Any questions? Okay, now let's see radicals containing variables. Well, square root of x squared, that's the absolute value of x, because we want to force x to be non-negative, right? Equals x if x is non-negative, equals negative x if the x is less than 0, which means x itself is negative. So negative x becomes positive. Cubic root of x, square root of x raised by 3. We were hunting, if we have radicals, the index is 2, we'll be hunting squares inside, right? So x raised by 3, we can write as x squared times x raised by 1. Square root cancel out each other, so we get x radical x. Well, this is always true. If the power and the index are the same and they are odd number, if the index and the power are odd numbers, and then they're the same, so that just equals the x, right? We do not need to force an absolute value sign. But if the power is positive even, let's see this example. Okay, we split x raised by 4 to be x cubed times x cubed and the cubic root cancel each other. So we have absolute value of x and cubic root of absolute value of x. Why is this? It's all because this is power 4. All right. This power 4 will change x raised by 4 to be a positive number. Okay, x raised by 4 is a positive number. Example, we see negative 2 raised by 4, then cubic root. First, we want to do negative 2 raised by 4. That's positive 16. No more negative. Then 16 can be written as 2 raised by 4. We can split it to be 2 cubed times 2. There's 2 index, the third root of 2. Okay. So you see in the end is the absolute value sign of negative 2 and the absolute value sign of negative 2. All because this power 4. This power 4 change negative 2 raised by 4 to be positive. So let's see this example. We have a number, we have a variable, and it's cubic root. So we see cubic root and x raised by 3, they cancel each other, right? So let's just get x. Now we're left with 16 cubic root of 16. So we have to think about 16, right? 16 is 2 raised by 4. So we split it into 2 raised by 3 and 2 raised by 1. So that one equals to 2 cubic root of 2. Or 72, next one, 72x squared. 72 is 2 times 36. So it's 36, square root of 36 is 6. 6 radical 2, absolute value of x, right? Because again, the square will force x value to be positive. 72x raised by 5. 72 is 36 times 2. That's why we have this. 6 radical 2, right? Then x raised by 5. X raised by 5 can be split into x raised by 4 times x. Well, x raised by 4, then square root is just x squared. Well, last one is x raised by 1, right? That is the inside square root of x, right? Because it's the first power, it cannot come out now. So in the end, we get 6x squared square root of 2x. Make sure this makes sense to you. If this doesn't make sense to anyone, let me know, please. Okay, let's see some questions. Which one to go over? 72, x raised by 5. Okay. Okay. All right. So 72, let me read more steps for this. $72 is 2 times 36, right? And the x raised by 5 is x raised by 4 times x. Right? So basically we read 72 as 2 times 36, x raised by 5 as x raised by 4 times x. Right? Then you see 30, what's the square root of 36? That's 6. So we got 6 radical 2. Then this x raised by 4 with index 2, that's x squared. Then we have this x left, so square root of x. So we get 6x squared square root of 2x. Does this help? Okay. Okay. So the next one is similar, right? So 72 x raised by 5, or fourth root of 72. 72 is 2 times 36. 36 is 6 times 6. So we have 2 cubed, we have 3 square. We have nothing raised by 4. So we just keep fourth root of 72. Fourth root of 72 is an irrational number. Then we get x raised by 5. We split into x raised by 4 times x. Right? So we get a fourth root of 72. Fourth root of x, then times x. So in the end we get x times the fourth root of 75x, 72x. Let's see this one. We have 72 again. So that means we can factor out 6. We can square root out 36, becomes 6. The n raised by 7. 7 divided by 2 is 3.5. So it takes a 3, we leave the half. That's n raised by 3. Then m raised by 6. Right? M raised by 6, 6 divided by 2, that's 3. But the m, we have to put absolute value around it. Then inside, under the square root, so 2 hasn't come out, n hasn't come out. So that's it, we got 6n cubed, absolute value of m cubed, square root of 2n. Oh, because this is square, oh, that's okay. Because you see n, I don't have to put absolute value sign. Why? Because n raised by other integer. So that means n has to be non-negative. But m is different. M raised by 6. So that forces m to be positive, to be non-negative. That's why when I say m cubed, I need to put an absolute value sign to force m to be non-negative. But what about cubic root? Cubic root, we don't have to sign worries, right? So 72, we have 2 raised by 3 times 9. Then n raised by 6 times n. Then m times m raised by 6. Right? Cubic root means raised by 1/3 power. So distribute this 1/3 power. Distribute to 2, we get 2 cubed, we get 2. Distribute to n raised by 6, that's n squared. M raised by 6 times 1/3, that's m squared. But then we still have a cubic root of 9, this one, and this one, cubic root of 9. And any questions? Okay, similarly, we have quotient properties. A raised by m divided by a raised by n, that's a raised by m minus n. Of course, a cannot be 0, right? If a is 0, it's undefined. Nth root of a, nth root of b are real numbers, but sometimes they may be irrational numbers. Nth root of a divided by nth root of b, because they have the same nth root, we can write them together. Just nth root of a divided by b. Or if we are written like this, we can split it like this. Let's see examples. Square root of 9 divided by 16. Well, we can do square root of 9 divided by square root of 16 because it's all under square root sign. That's just 3 over 4. Square root of y raised by 4. Well, square root of 49 is 7. Square root of 4 raised by 4, that's y squared. Square root of x raised by a divided by m raised by 5. X raised by a divided by 2, that's x raised by 4. M raised by 5 is m raised by 4 times m. So square root of m raised by 4 becomes m squared, but still one more inside the radical sign, m, square root of m. Anyone has any question? Okay, let's see this one. This one, numerator is a square root, denominator is a square root. So we have the same square root. That means we can put a square root outside, and this numerator and denominator are inside. So we see 98 divided by 2, that's 49. Z raised by 5 divided by z, that becomes z raised by 4. Square root of 49 is 7. Square root of z to the 4th power is z squared. Anyone has any question? Let's see this cubic root. This cubic root all together, right? Z to the 7th power in the numerator, z to the 21st power in the denominator. You see the power in the denominator is bigger than the power in the numerator. So what do? We use the denominator subtract, the exponent of the denominator subtract the exponent of the numerator. So we keep in the denominator. So z to the power 21 minus 7, which is z to the power of 14. So then 54 is 3 cubed times 2, 27 times 2. Right? Z to the 14th power can be written as z to the 12 times z squared. Why we want to break like that? Because those are numbers least common multiple of 3. So 3 cubic root becomes 3. Z to the 12th power, then cubic root 12 divided by 3 is 4. So it's z raised by 4 power. Then what's inside left? 2 is here, z squared here. So we get 3 over 4 over z to the 4th power, then cubic root of 2 over z squared. Just every one of you, make sure you're able to do all those questions on your own, okay? Make sure of that. A to the 11th power divided by 8 to the 7th power, we want to reduce the same base. So that's a raised by 11 minus 7, which is a raised by 4. But 12, we can split it into 2 square and 3. Then 2 square root becomes 2. Then a to the 4th power, Square root becomes a to the square. Then we have square root of 3 left. So write as 2 radical 3a squared. Anyone has any question? Pretty simple and direct, right? Let's see this one. We're looking for same base. We see m to the 13 power in the numerator, m squared in the denominator. So we do m to the power 13 minus 2, which is 11. Well, p to the fourth power in the numerator, but p to the 22nd power in the denominator. So what do? We keep p in the denominator. We do 22 minus 4, which is p raised by 18. Now we apply square root, right? M raised by 11, we split into m raised by 10 times m. So m raised by 10 square root, that's just m raised by 5. P raised by 18 square root, that's the absolute value of p raised by 18 divided by 2, which is 9. What's left? See 15 and the m left inside, the radical sign. Anyone has any question? Yes, Ajita. I'm sorry, can you repeat? I can't hear you.
Good afternoon, can you hear me?
Yes, I can hear you now.
So, for when you have 15m for the last equation, wouldn't it be 15m to 1 over 2?
1 over 2? Where do you get a 1 over 2? Oh, you mean instead of written as square root of 15m, write as 15m raised by half?
Yeah.
Yeah, sure. But usually the last part. So when we write as something raised by half, that we want to do calculation. But once we finish the calculation, we want to write back as a square root. We don't keep, in mathematics, if we keep fractional or negative exponents, they're considered as not defined, not simplified. Does that make sense? We don't want to use, right? We only do that. We use negative exponent, fraction exponent only for calculations. Okay, good question. So now actually maybe everyone try this one to see what we come up. Everyone try this one. Cubic root of 240, m raised by 13, p raised by 4, divided by m squared, p raised by 22. Let's maybe take like 3 minutes. Okay, it's 3 minutes. Let's all do together. Okay, so 240. That's 2 raised by 3. That's, well, 8. That's 8 times 30, right? 8 times 30. So 8 is 2 raised by 3. And 30 has no cube in it. Because the index is 3, so we're hunting for cubes or multiples of 3. The exponents to be multiples of 3. So m raised by 13, and then we have m squared in the denominator. So that becomes m raised by 11, right? 13 minus 2, that's m raised by 11. M raised by 11, we want to write as m raised by 9 times m squared, because we're looking for multiples of 3. Oh, okay, Ajada has it. Yeah, let's finish. Let me finish so compare with your answers. Then m raised by 9, 9 divided by 3, that becomes 3. So I have this m raised by 3. But then this 2 cube and the index 3 simplified to be 2. The denominator will have a p, so we have p raised by 4 in the numerator, p raised by 22 in the denominator. So we do 22 minus 4 with p raised by 8. Well, 18 divided by 3, that's 6. So denominator, we have p raised by 6. Right? And this one doesn't need to be there. Let me see if I can. Oh, hold up. 30m squared. 30m squared. Right? Actually, if I write everything inside 2m raised by 3 divided by p raised by 6. Oops. Divided by p raised by 6. This looks a little bit better.
Professor?
Yeah.
I have a question.
Yes.
I don't think I really understand how you got what you did to the 240m.
240. Okay. 240 is 8 times 30, right?
Right.
Right. So what is 8? 8 is a 2 cube, isn't it?
Right.
Yeah.
Okay. Thank you.
You're welcome. Okay, Ajada's answer is a little off. All right, just didn't finish. Okay, let's see this example. Numerator, we have cubic root of this. Denominator, we have a cubic root of that. Because all cubic root, we can put them together. We can put it under one cubic root sign. Now we want to simplify it, if we could. We have m raised by 5 in the numerator, m raised by 12 in the denominator. So we do 12 minus 5, we get m raised by 7 in the denominator. We have q raised by 10, q squared. So we get to q raised by 10 minus 2, which is q raised by 8. Now we want to split the exponents into, we're going to split. So q raised by 8, we want to do q raised by 6 times q squared, right? So 8 is 6 plus 2, so we can split into q raised by 6 times q squared. Similarly, m raised by 7, we want to write as m raised by 6 plus 1, split into m raised by 6 times m. Now you see q raised by 6 becomes q squared outside, right? Also 2 cube. 2 cube and cubic root becomes 2. And m to the 6th power becomes m squared outside, because 6 divided by 3 is 2. Well, what's left inside? We still have q squared divided by 25m inside the index. Okay. Anyone has any questions? Just make sure you can do all the examples, or maybe you can practice your homework. All right. And also review class notes is a good idea, because the class notes, you know, it's very condensed. All right, let's see next one. We have a fourth root of this. Now we see that numbers 32 and 162 can be simplified, right? Because both are even numbers. So let's simplify. We can divide by 2. 32 divided by 2. Well, we can write 32 as 2 raised by 5, which is 2 times 2 raised by 4. 162 is 2 raised by 81. 81 is 3 raised by 4. So 2 over 2 becomes 1. So I have 2 raised by 4, we have 3 raised by 4. You see, because the index is 4, so I was counting for power 4. So 2 raised by 4 over 3 raised by 4, and do with the fourth index. So we have 2 raised by 2 over 3. Yeah, 2 over 3 outside the radical sign. Then a raised by 6, we can write as a raised by 4, right, times a squared. A raised by 4 fourth root comes out to be a. B raised by 4 fourth root come out as b. Then we have a squared left under the fourth root sign. Anyone has any question? Okay, that's all for today. We talk about nth root. Okay, this is the fourth root of something. And they call this 4 index. It's opposite with power. Anyone has any question? Okay, same rule. If you let me